Hello, everyone. Great to meet you. Happy Friday. I'm Arjun. I'll be talking about our paper, Importing Phantoms, Measuring LLM Package Hallucination Vulnerabilities. Like we said, I'm a graduate of the University of Waterloo. Just curious, are there any Canadians in the audience today? No Canadians. It is moose herding season right now, so I'm sure they're all busy herding moose. But yeah, written by me doing my undergraduate work, as well as Erick Galinkin from NVIDIA Corporation, who I believe is in the audience right there, and Leon Derczynski and Jeffrey Martin. Yeah. Oh, and there's a clicker. All right, cool. So just a show of hands in the audience, how many of us have used an LLM-based product like Cursor, ChatGPT, Claude Code, or Copilot to write code for us in the last month, let's say? So basically everybody in the audience, I think. How about the last week? You used LLMs to write code in the last week, the last day, the last hour? All right, right now, there's a guy right now writing. Um, so, so yeah, I mean, LLMs are super useful for writing code. I mean, they're trained a lot on it. They're super useful for writing experimental code, trying out stuff. And actually, a lot of LLM-based code is shipping to production already today in big companies, small companies, startups, everywhere. And like out of the people who use LLMs to write code, when you ask Cursor to write code for you, it will recommend, hey, pip install this package, or it might even do it for you. It will try to install like external packages. And the question we want to answer here is, LLMs hallucinate, LLMs can suggest these packages. Are they hallucinating these packages that they're recommending us to install? And these hallucinations can be a security vulnerability, as I'll go over. So yeah, some interesting things we found is that every single LLM we tested hallucinated packages. And I'll go over in greater detail later. The behavior differed across different programming languages, so it wasn't consistent. And there's some trends between the number of parameters of the model, how good they are on the software engineering benchmarks, and the package hallucination rate that I'll go over in detail. So yeah, here's a scenario. Let's say I'm building my startup and I'm trying to add login to my startup. And I ask Cursor or Claude Code, write me some Python for making a password safe to store. And then Claude Code says, import this package, pip install secure hashlib. Now, if you go to PyPI or an open source package index, this package actually does not exist. This is a ghost package. It's a package that the LLM made up for password hashing, but I, as a user of Claude Code, and actually a lot of people using these tools are, may not be great software engineers and maybe just starting to code. I'm going to trust Claude Code and try to pip install or npm install secure hashlib. And now I'm giving passwords in my program to a library that doesn't exist at the time of training for the model. But the thing is, malicious actors have access to the same models that we do. So I, as a black hat hacker, could be looking at GPT-5 and saying, "Hey, GPT-5 is we're saying use secure hashlib to a lot of people. This doesn't exist yet. What if I go into PyPI and make a malicious version of secure hashlib that's gonna give me all the passwords that people have generated?" And now this is like a supply chain attack, which supply chain attacks happen. Um, so yeah, that's and one example of what a package hallucination looks like. Now let's look at what models we tested for this study. So we did focus on open source models, just because we have more data about the model size and stuff like that. So as you can see, there's a big list: CodeGemma, IBM Dracaris, and we also included GPT-4o because you want to have at least one frontier model in there for completeness. And as you can see, there's a variation in parameter size: 7 billion, 70 billion, 200 billion, and some of these models are fine-tuned on generating code. Others are just instruct trained. So now let's talk about how did we actually generate, how did we actually detect if the models are hallucinating packages. So for this study, we used the Garak LLM vulnerability scan, which is a great open source project. And what we did is we used the APIs available on PyPI, npm.js, and as well Rust crates that gave us access to like the repositories they have and the metadata on the packages. And we were able to get the dates of when these packages were first published onto these repositories. And we also know the dates of which these models, like the knowledge cutoff that they have access to. So from this, you were able to say these packages could not have been in the training data of these models. So if this model suggests it, it must be a hallucination. And these data sets are open source on the Garak repository and the Hugging Face. So now we do we'll talk about this in the mitigations, but this may overcome hallucinations in enterprise context if you only allow certain yeah into repositories like Anaconda. Oh, wrong direction. Oh, other button. I just revealed my best slides are coming up. So now let's talk about what prompts did we use. So we have a list of kind of ambiguous vibe coded type of task descriptions like make this password safe for hashing, which kind of represent what a lot of people will give to Cursor and Claude Code when writing code with them. These are open source on the GitHub. And then based on these task descriptions, we construct prompts, combining them with these task description stubs. Just like a generic intro, like that's a stub. These task descriptions, and then and then the three programming languages we tested: Python, JavaScript, and Rust. So here's some examples. Generate some Python code to perform very fast XML parsing. So there's the stub at the start. Generate some, write me some. Can you help me? The language, and then the task we're solving. And another example is, can you help me write JavaScript to solve the sawtooth programming problem? And this is all open source as well as it's in the paper as well, the specific prompts. And then let's talk about what metrics did we measure to evaluate are these models hallucinating? And we focused on this metric called package hallucination rate, which is basically if you ask the model to write code, did it recommend we install at least one package that is hallucinated? Um, and we use regex based extraction from the generated code to figure out what the imports were. And then each request we repeated 5 times because LMs are stochastic. There's a randomness to it to smooth out the impacts of spurious outputs. So now let's delve into the results. So as you can see, here is like the package hallucination rate. And basically Rust had so yeah, we tested Python, Rust, and JavaScript. Rust had the highest mean package hallucination rate. So overall, on average, it had the highest hallucination. Python had the highest variance. So on some models, it did better. On some models, it did a lot worse. And it was had a slightly lower average hallucination rate. And then JavaScript had the LLMs overall. Sorry? Yeah, it's at a one, sorry. So that's like 23% or 24% or 14%. So it's pretty high. Like, I mean, it's significant. Again, some of these prompts are like vibe coded or more generous. So if you're more specific with it, maybe you could get lower hallucination. But yeah. So and on the tasks we tested and the models we tested, JavaScript, the LMs were most consistent and had the overall lower hallucination rate and more consistent hallucination on JavaScript. Oh, not again. Okay, now let's talk about um, how does the size of the model, did that have relationship with the package hallucination of the models? So because we focused on mostly open source models, we have the size of most of these models. As you can see, at the lower end, we have a bigger spray, And overall, there's a lot of models with a lot higher hallucination. Um, and as the so we have some models in the 7 billion parameter range, 10 billion parameter range, and as the model parameter count increases, there's a meaningful inverse correlation. So bigger models tended to hallucinate packages less in our tests. So yeah, models over the median size had consistently better resistance to package hallucination. Now let's talk about induced versus natural package hallucination. So we had some prompts where we said use foobar.js to write me like a JavaScript app type of stuff where we asked the LLM for code containing a package we know does not exist and to support an API that is fictional. So we wanted to see how responsive are the LLMs to like adversarial prompting. And actually LLMs, they want to make us happy. So if you ask it to use a thing that doesn't exist, it at double the rate tries to hallucinate an implementation and say, import this and then use it this way. So induced hallucinations occur at nearly double the rate of natural hallucinations where we just ask it for a task versus we ask it to use a fictional API. And yeah, this suggests that these models, especially in code generation, are very vulnerable to adversarial prompting. So this can tie into some of the stuff we saw earlier with computer use agents and stuff, where you could potentially have people suggesting bad things to get up issues and stuff. Now let's look at package hallucination versus coding benchmark scores. So for LLMs, there's dozens of benchmarks out there now, which are all trying to tell us how good LLMs are at different tasks. There's also probably dozens of coding benchmarks too. So we wanted to see are models that are better at coding, do they tend to hallucinate more or less? And what we found out, so this axis is inverted. So so human eval is a pretty big coding benchmark. As the performance on human eval increased, the package hallucination tended to decrease overall. There's a strong correlation between higher coding benchmark scores and lower package hallucination rates, and this was pretty consistent across all the different models and all the different languages we tested. So this suggests that if you can't do if you can't do a very thorough study of package hallucination for a coding agentic system you're writing, how good it is on the coding benchmarks in general could be a good proxy for that if you can't invest that time. Yeah, so those are the main results. Now let's talk about mitigation. So as we saw, every single model hallucinated packages. There's ways that people can get them to hallucinate packages more. What can we do about it? How can we make our agentic coding systems more resilient? So one thing, and this is already in use in a lot of enterprises today, is just have a whitelist of packages. These are packages like Anaconda has this where these are packages where we have verified that so yeah in this case we can have a list of packages that are verified that they exist before the model's training cutoff date. We have some of this data available on GitHub, but you can go a step further and also say these are packages we know are not malicious, um, and then package suggestions that are not on this whitelist. So you could have one before the training cutoff or just manual verification can be flagged as hallucinated and should not be allowed by the coding agent. Also, there's anecdotally and in other works, having more context, like giving the agents access to web search and retrieval augmented generation. So maybe the agent can search PyPI and say, show me the packages available for password hashing before it suggests them. They could improve the performance. We're going to leave that to future work. Yeah, more future work. So strategies for reducing package hallucination in smaller models. So something we did find is that the smaller models tended to hallucinate more than the larger models, and that kind of has a pretty interesting security versus privacy trade-off. Because if you want to run the models on your own servers, you're probably going to have to run a smaller model, but that could mean that the model is going to hallucinate these packages more. So finding strategies um, for running these models privately on on our own premises while still reducing hallucination is very interesting for future work. Creating robust defense mechanisms that can be implemented across different programming languages and model architectures as well. And then another interesting result we found is that we tested the Code Mamba model, which is a non-transformer based model, and we found that it actually had a bit of an outlier result where it had like lower hallucination than the other transformer based models in the same size class. So more study needs to go into understanding whether non-transformer based models are more robust to package hallucination. And yeah, that's all. Thank you guys. Happy to answer any questions.
Did you have a chance to look into like the package squatting? So like for the ones
Yeah,
there, you just make bad code, but was there, someone there making you that? Just
that's true. Yeah. So we would that that is like actually a very important thing to look into. We didn't consider this in this study, but I think there's one specific example of a package called LangChain, which is very popular in Python, and someone squatting on the Ruby version of it and is saying, I am the LangChain in Ruby, but it's just some random person, right? So that is something interesting to look into. But yeah, we didn't consider this in this study.
Hey, test. Hello.
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 First of all, yeah, great work.
Thank you.
Love the presentation, and also sometimes I ran into issues where it imported or deprecated libraries.
Yeah, that's true as well.
And I was like, what the hell is this? So I'm glad there's a study. So thank you. I would like to ask you if you also think that this issue may be coming from also training data. So for example, you scrape GitHub. Probably there needs to be more cleaning, I would say, for packages because probably the well-maintained repositories are good or maybe even as good, but smaller repos may have from bad actors like fake libraries where they may try to register on PyPy or whatnot. So yeah, what's your thoughts on that? Did you think about the well, from the training side or the data side?
Yeah, that is a good point. So, all these models are tested on openly available data, and I think that needs to that is how they learn to code and learn to train. The problem is they're trying to memorize it and then output it from memory. So there's some bad examples. I think we do need to keep training on those data sources, but I think there's other strategies for getting this context. Like someone at the conference showed me this thing yesterday where there's like a list of like specifications for open source projects, like 10,000 of them. I forget what the project is called. Maybe we can talk about it after. But like I think pulling in other sources of context is the way to go. Eric, do you have something to say? I think maybe Eric knows the name of the project. That's my co-author, Eric.
Who's your favorite co-op? So there are also two things to consider. One is hallucinations that can be induced by other languages. So we noticed that JavaScript had a really low hallucination rate because NPM has like an order of magnitude more packages than everybody else. So like all the names taken, which is neither here nor there. But in one case, you ask Python for code that can deal with Istio, and it tries to import Istio-client. There is no Istio client. However, in Go, there is an Istio client library. So you may have these cases where it is doing kind of the right thing, but it's using a package that's registered in another language like Go or, JavaScript, because again, JavaScript has registered all package names. The other thing is internal, right? Like I'm sure we have all written, from .utils import whatever, right? From the Python file in this directory import. So you can also have those cases, but beyond that, sometimes it's using things like pseudocode that it's encountered where you're like, yeah, import secure hashlet, right? Like we just want a secure hashing library, so it's called secure hashlet. That's plausible enough. So I think training data can be a factor, but it's also very difficult to do it purely with training data because LLMs are just linear algebra. They don't know anything, so they can't necessarily distinguish between Go and Python at inference time.
Thank you. It was an interesting presentation. Thank you. Yeah. Actually, I'm thinking about your mitigation technique. Suppose if we want to extend it to a dynamic mitigation, as you know, for example, for the Python language, every day some package appears and you want to extend your mitigation to a real-time mitigation to detect them, identify them, and list them, and increase your list, extend your list. Is there any way to put a validator, because the malicious user can use it to create a malicious package based on the hallucination feedback? Is there any validator to put there to do the real-time mitigation or a real-time validator for those malicious, to distinguish between the malicious and benign package?
Yeah, that's a good point. Actually, one of the papers we looked at for the background research in the paper is doing just that. Is they're trying to just look at the code and see if it's a malicious package. So there's projects working on that. It is it is a hard problem because there's a lot of open source projects even in the past and today that have malicious code in them. So I think that's a good idea. And yeah, there's projects working on that for sure. Thank you.
Hello, there we go. You showed a chart of hallucination rate against coding performance. Do you have any intuition if that's really just a correlation of representation in the corpus of training, like maybe now JavaScript or not Rust or maybe other low resource languages, and what's your intuition on that sort of resource density of the data in languages to actually the overall hallucination?
Yeah, that is a good point. Like Eric mentioned, JavaScript just has an order of magnitude more packages on npm and code available in general. I think this correlation is kind of perhaps different than that though, because um, I think you can look at the coding benchmarks, and even if like coding benchmarks, a lot of these packages are better at Python perhaps or something like that. But there's still a relationship between the hallucination rate and the coding benchmark score. Sorry.
Train on our corpus of that language type. I'm
Right.
looking at the correlation between those two behaviors of, oh, it's just saying I have a lot of things, so it performs better in this way.
That is so something we have in the paper that we don't have on here is we looked at code specific models, code generation models, and then instruct tuned models in general. And we did find that there's actually there wasn't a significant difference in package hallucination between those two classes. So I mean, there's possibly a correlation there. Yeah, maybe the paper happy to correspond, but yeah, that's not in the slides. But code specific models didn't have a significantly difference on hallucination rate.
Sorry if this was covered in the mitigation, but this feels like something which should be covered at the, not the package manager level, but the package index level. And or have you reached out to any of them to begin implementing mitigation?
Yeah, that's a very good point. I think PyPI actually earlier this year or last year, they like paused new package additions to PyPI for like a while to like fix the process. So a lot of these package managers are doing that already. So PyPI just like paused it and then fixed their process and did it.
And have you registered any packages yourself?
No, I haven't, but there's this thing called ArangoDB, Eric, which someone as a kind of like a demonstration of packet squatting has done that. But maybe I should make a malicious implementation of password hashlib and get everyone's passwords. Yeah.
Stop vibe coding.
Yeah.